Hello friends, in the last video we have seen that some examples depending on the exercise 3.4. Now we'll see the remaining examples. I hope that you will understood all the examples, whatever that I had explained. Now let us start the remaining example from the exercise 3.4. Now let us start the example number 7. How many different words are formed if the letters R is used thrice? I made some mistake to writing this. That is a THRI and the letter S and T are used twice. That is, the problem is that how many different words are formed if the letter R is used twice? S and T are used twice, thrice and twice. R is used now. I'm changing it. Thrice. That is P is equals to 3. म्हणजे आपल्याला एक वर्ड बनवायचा आहे की त्याच्यामध्ये R हे 3 वेळा आलेला असेल आणि S and T हे 2 वेळा आलेला असेल. R is equals to, R is repeated, that is thrice, that is P is equals to 3, S is equals to, that is S is repeated 2 times, therefore we treat it as it is Q is equals to 2, and T is used again the twice, therefore we take it as number as R is equals to 2. Therefore the total number of letters for this word, what will the total number? That is a 3 plus 2 plus 2. That is equals to 7. Therefore, the number of different words formed is equals to n factorial upon p factorial q factorial into r factorial, that is 7 factorial upon 3 factorial into 2 factorial into 2 factorial, and in this way that is a 7 into 6 into 5 into 4 into 3 factorial divided by 3 factorial into 2 factorial. These two get cancelled and you will get their multiplication. That is a 210 words we can form by using the given condition. That is a 210 different words can be formed. Now next question, question number 8. Find the number of arrangements of letters in the word Mumbai so that the letter B is always next to A. In this way we require the arrangement. Now see this again. Find the number of the arrangement of the letters in the word Mumbai so that the letter B is always next to A. Whatever that B, A or AB is considered as a 1 unit. That is now in the word Mumbai, B is next to A treated as AB as a 1 unit. B or AB, I think that there is some mistake in the textbook, or you may consider B or AB next. B is next to A or A is next to B. It doesn't matter for that. That is, the B is next to A. It is treated as AB as a 1 unit, and the remaining 4 letters, that is the 4 plus 1, that is equals to 5. That is, in this case, that is the B is treated as 1, M, U, M and I. These are the 4 plus 1, that is equals to 5. Again, M is repeated twice. Therefore, these letters can be arranged as 5 factorial upon M is repeated 2 times. Therefore, it is a 2 factorial divided by 2 factorial. Now, see this. That is, again, M is repeated and the P is equals to 2. Therefore, the number of different ways of arrangement of letters in which B is always next to A. That is equals to 5 factorial upon 2 factorial. That is a 5 factorial upon 2 factorial. That is 5 into 4 into 3 into 2 factorial upon 2 factorial, that get cancelled. And you will get 60. Therefore, number of the letters formed is 60. Question number 9. Find the number of arrangements of letters in the word Constitution that begin and end with N, that begin and end with N. Now in the word Constitution, the number of letters, that is, if you count it, then you will get N is equals to 12. Now we require the word such that it begins with N and end with also N. Now here O repeat twice, therefore it is treated as P is equals to 2, and repeat. Then it is a twice, Q is equals to 2. And T repeats thrice. That is R is equals to 3. Therefore, I repeats, S is equals to 2. Therefore, the total number of words from Constitution that is n factorial upon p factorial into q factorial into r factorial into x factorial. That is a 12 factorial upon 2 factorial, 2 factorial, 3 factorial into 2 factorial. These are the total number of the words. Now what is our job? Our job is find out that our word starts with n and ends with also n. That is a begin and end with n. The remaining letters are 10, and in that 10 letters O is repeated. That is the repeat is 2 times. That is the p is equals to 2. Next, t repeats. Q is equals to 3. I repeats. R is equals to 2. And next is the number of ways of different arrangements in which it begins with n and end with n. Therefore, n factorial upon p factorial q factorial into r factorial, that is a 10 factorial upon 2 factorial that is the answer. Now here we will see that answer. See this here. That is 10 fact. That is equals to 10 factorial. I forget to write that is a 10 factorial. It is 10 factorial upon 2 factorial, 3 factorial, and again 2 factorial. Now the question number 10. Find the number of different ways of arranging letters in the word arrange. How many of these, that is how many of these arrangements do not have the two R's, not A's together. That is, find the number of the different ways of the arranging the letters in the word arrange. How many of these arrangements do not have the two R's and not the A's together. This should be not combined. Now, let's see this here. Now, in the word arrange, the number of letters is n is equals to 7, in which A repeats twice, that is the P is equals to 2, R repeats twice, Q is equals to 2, therefore the number of weights in which the letters of the word arrange are arranged in this manner. That is, we will find out the total number of the words formed by the given letters, means or n factorial upon p factorial into q factorial. That is 7 factorial upon 2 factorial into 2 factorial. That we will get all the number of the letters, all the number of the words by forming the given letters. And that is calculations. That is 1260. Now 2 R's nor 2 A's together arrange AA, RR, N, G, E, 1, 2, 3, 4, 5. Total is 5. That is, A is treated as 1 unit and RR is also treated as the 1 unit. Now, first of all, we'll find out that they are together and then we'll subtract from the above. Then we'll get the correct result. That is the number of arrangement of letters in which no 2 R's, nor 2 A's are together. That is a 5 factorial upon 2 factorial into 2 factorial. We will calculate this. Now in this case, A and R are together, but we want to find out they are that is 30. These are the together. A and R are the together. Now we'll subtract here. Hence, the number of arrangement in which two A's nor 2 R's together. That is equals to 1260 minus 30. That is a 1230. Therefore, Question number 11. How many distinct 5-digit numbers can be formed using the digits that is a 2, 3, 2, 3, 2, 4, 5. That is, we want to form the 5-digit number using the given digit, that is a 3, 2, 3, 2, 4, 5. Here the digit number of the digits, that is n is equals to 6. In this, that is a 3 is repeated and 2 is also repeated. 3 repeats twice, 2 repeats again twice, that is q is equals to 2. Therefore, the number of 5-digit number is equals to 6p5. Now there is a repetition, 2 and 3 upon 2 factorial into 2 factorial, and we'll calculate out of the 6-digit we want to form the 5-digit number. Therefore it is a 6p5 upon 2 factorial upon 2 factorial. Now 6, 5, 4, 3, 2, 1. This is the calculation. And that is equals to 180. Therefore, the required number of 5-digit number is equals to 180. Now the question number 12. Find the number of distinct numbers formed using digits 3, 4, 5, 6, 7, 8, 9, so that odd positions are occupied by the odd digits. Now see this very simple, that is odd positions are occupied by the odd digits. Now the total number of digits is 7 and we have the 7 boxes. Odd, even, odd, even. Okay. That is the total number of odd digits are 4. And the digits are 3, 5, 7, 9. Even digits. They are now they can be arranged. That odd digits can be arranged n factorial. That is a 4 factorial. No repetition is there. Therefore 4 into 3 into 2 into 1. 24 ways can be arranged the odd digits. Now next, see this even digits. There are the 3 even digits, that is the places. There are the 3 even positions. or even that is 4, 6, 8 digits. Again, no repetition is there. Therefore, n is equals to 3, and then they can be arranged as that is a 3 factorial. Therefore, 3 into 2 into 1, that is equals to 6. Therefore, the total number of ways to form distinct number so that odd positions are occupied by odd digit and even position is occupied by even digits. That is a 24 into 6, that is equals to 144, and hence the required answer is 144. Now the question number 13. How many different 6-digit number can be formed using digits in the number that is 659942. The total number of digits are 6 and we want to form the 6-digit number. That is a 2 repetitions is there. That is the last 2 digits are divisible by 5. Must be divisible by 4. We can form using the given digits. Now see these digits. That is the last 2 digits. 96. It is divisible by 4. 92. Divisible by 4. 64. 52. 24. That is the total of the 5 numbers. These total are 5. That is the total or the 5 remaining places can be filled by that is equals 4 factorial. That is a 5 into 4 factorial. Now here see this. These total numbers are 5. That's why it's a 5. We want to find the 6-digit number, and the remaining 4 digits we can form. That is equals to 4 factorial. Here you will say that why you have not taken the 9, because the 9 is included somewhere there. That's why we are not dividing. That is the digit is repeated. Therefore, their total multiplication is 120. Therefore, 120 numbers the numbers which are divisible by 4. The next question number 14. Find the number of distinct words formed from the letter in the word Indian, that is, we'll write in capital. How many of them have the 2n together? That is, that 2n should be always together. Find the number of distinct words formed from the letters in the word Indian. How many of them have the 2n together? Now see this Indian. The number of letters, that is n is equals to 6. N is repeated 2 times. I is also repeated 2 times. Of which I repeats twice, n repeats also twice. Therefore, n is equals to 6, p is equals to 2, q is equals to 2. The number of different words formed with letters of word Indian, that is n factorial upon p factorial into q factorial, that is a 6 factorial upon 2 factorial into 2 factorial, that is 6, 5, 4, 3, 2 upon 2 into 2. 1, 2 is remaining. I forget to write down. I will change it. Again 2 factorial. That is a 2 again. That get cancelled and you can have the multiplication. Multiplication is 180. That is 180 different words can be formed with the letters of Indian. Now secondly, we want to say that the two n's are always together. That's a 2n are together. Now consider here 2n as a 1 unit and the remaining, and what are the remaining? That is I, D, that is I am writing n. This is 1, I, D, I, A, total 4, 1 plus 4, that is equals to 5, and remaining 4 That is the total is 5. That is NN is 1 and IDIA is 4. 4 plus 1, that is equals to 5. Now these 5 can be arranged. That is a 5. That is 5p 5 upon 2 factorial. I is repeated twice, therefore it is divided by 2. That is 5 factorial upon 2 factorial, and this can be written as 5 into 4 into 3 into 2. And upon 2, these 2 get cancelled. That's why you are getting 60 ways in which they are together. Therefore, the total number of words in which 2n are together is equals to 60. Next question, number 15. Find the number of different ways of arranging letters in the word platoon if A, the two O's are never together. Two O's are never together. That is in the word platoon, that is a Platoon. The number of letters n is equals to 7. N is equals to 7, of which O repeats twice, that is a P is equals to 2. Therefore, the total number of words formed by using the letters of the word platoon 7 factorial upon 2 factorial, that is 7 into 6 into 5, 4, 3, 2, 1, that is these two get cancelled, and that is equals to 2520. Now when these O's are never together, therefore see this here. Now in this case these O's are together. That is 1, 2, 3, 4, 5. We solve this example in a different way. When they are together, then we subtract from the above. Therefore, here O's are together, and that is OO. It's treated as 1 unit, and remaining are 5. 5 plus 1, that will be 6. When the O's are together, the remaining letters are the 5. Therefore, the total 5 plus 1, that is equals to 6. It is treated as 1. Therefore, the number of arrangement in which two O's are together, that is a 6 factorial. It is not necessary to divide by 2 factorial because these O's are treated as 1 unit and that is equal to 720. Hence, the number of different arrangements in which two O's are not together is 22520 minus 720, that we subtract with this. Therefore, now the B part, consonant and vowels occupy alternate positions. Therefore, in the word platoon, that is A, O, O, these are the vowels, and P, L, T, N. P, L, T, N are the consonant. A, O, O are the vowels. Now see this here. P, L, T, N. A, O. Now see this here. These are the different positions. That is the P, L, T, N. N is equals to 4. And all the vowels, that is a consonant. Now the remaining, these are the vowels. That is 4 consonants can be arranged. No repetition, that is a 4 factorial ways, and 3 vowels can be arranged, that is 3 factorial upon 2 factorial, because 2 is arranged 3 factorial upon 2 factorial. Therefore, now say this here. Therefore, the consonants and vowels occupy alternate positions is equals to 4 factorial into 3 factorial upon 2 factorial. That is 4 into 3 into 2 into that is 3 factorial upon 3 into. Now these get cancelled and you will get the correct answer. That is 72. Therefore, the required answer is equals to 72. And in this way, I had completed this exercise 3.4. I hope that you will understand whatever that I am explaining. Now we'll see in the next video. Till then, goodbye. In this way, I have tried to explain all these examples, remaining examples. I hope that you have understood all the examples, whatever that I had explained. Now we'll see in the next video. Till then, goodbye.